Let's take a look at Project 2, Part 4. This corresponds with Lesson 10, so you'll be able to work on this once you've seen the Lesson 9 for Logarithms Part 1 and Lesson 10 for Logarithms Part 2. Remember, as always, with these projects that, particularly in the research section of each lesson, that's where you're going to find examples that most closely correspond to what you end up seeing in the project. So just something to keep in mind. And of course, as always, remember that these videos are meant to be supplementary. Please look through, read through, maybe even try the project before viewing the help videos. So really quick, a reminder on what a logarithm is. So a logarithm is an exponent, period. So no matter what statement you see on the left-hand side, logarithm base 1 million of x, y, z, whatever, equals 2, all we're really doing is saying there's an exponent and it's 2, and here's a really, really fancy way of representing it, okay? So a logarithm is an exponent. A logarithm is an exponent. A logarithm is an exponent. Repeat that to yourself, okay? A logarithm is an exponent to which a specified base is raised to obtain a given value. So this is my base, that's my value. So if I have log base 9 of x equals 2, I'm saying that 9 to the 2 equals some value of x, okay? I'm raising this exponent, or I'm taking this specified base 9, and I'm raising it to this exponent to obtain a given value x. All right, a logarithm is an exponent. So to look at the way, and let me kind of do some erasing here. To look at the way we switch back and forth between exponential and logarithmic form, take a look here. Okay, so b, the base of my exponent, is the b base of my log. X, my exponent, becomes the value that the logarithm is equal to because logarithms are exponents, right? And then a is just, I kind of refer to it as a result. It doesn't have a proper name, at least that I'm aware of, so I usually refer to it as the result. Okay. All right, so let's move forward. This is just further kind of animating what a logarithm is. So the animation going through right here is just showing you how you would rearrange log base 2 of x equals 6 to become 2 to the 6 power equals x. All right, but let's move forward. So in this project, once again, we're working with spells, and we're more or less being given logarithmic expressions and asked to solve for a value. So you are asked to take a look at this log base 5, and the graphics didn't come through quite right. So this actually says log base 5 of 6x equals log base 5 of 24. So this is the problem you were given, and it says what must x be? I'm going to show you a similar example. So I have written log base 9 of 5x equals log base 9 of 25. All right, so as usual, the examples I make up, the similar examples that I write out, I literally just typed off the top of my head right before doing this presentation, okay? So they're just meant to kind of be of a similar format to the one that you're going to be working on. So notice, remember that this position, that this 5x, that this 25 are in, is the result, right? So when we were looking at exponential form, for example, if I had a to the b equals c, the a in this case, sorry about that, guys, as you know, my PowerPoint likes to do that to me, my base is 9, right? So in this case, 9 would be a. I don't know my exponent, and then the result, as I've called it, is c. So right now we've got two expressions that are showing us what their result is, what their c is. They're showing us a and they're showing us c. So if the log base 9 of 5x is equal to the log base 9 of 25, then 5x must be equal to 25, okay? And this is that's the same, but I'm going to show you an example in exponent form just to give you an idea. It's kind of like saying, if I had 3 to the x, and I said 3 to the x was equal to 3 to the 10th, and I asked you what x must be, I think you would intuitively know, oh, x must equal 10, right? Now, these numbers are not exponents, but it's just a similar and more familiar example. So, if this just said log base, in fact, if this said log base 9 of, I don't know, d equals log base 9 of 25. Again, I think it'd be really easier for you to say, oh, well, if log base d, or log base 9 of d is equal to log base 9 of 25, then 25 and d must be the same number. It's the same thing here, only a little, this r variable has a coefficient. So 5x must be equal to 25, right? And to solve this, you would just do it as you normally would. So dividing both sides of the equation by 5, we would find that x equals 5. And I can double check this. What if I plug in 5 for x? Well, I would get log base 9 of 5 times 5 equals log base 9 of 25. 5 times 5 is 25, so this produces the identical statement, and I can see that my answer is correct. Okay, so you'll do a similar operation to solve for your logarithm. Alright, so we have another one. This time we're in exponential form, but it's just like I was explaining before. I gave you an example and I said, if 3 to the x was equal to 3 to the 10, that it'd be pretty obvious. It'd be pretty obvious that x must equal 10, right? Similar thing here. So you're given the expression 19 to the 3x plus 2 equals 19 to the 8x. I'm going to use a similar example. All right, so as always, make sure you don't type in my answer on mistake. So if 11 to the 2x plus 4 is equal to 11 to the 14x, then these exponents must be equal. Now, one thing I didn't note in the last slide, but is true both if I'm talking about exponential or logarithmic form, notice that this only works if my base is the same. Okay. So because I have the same base, I'm allowed to claim that 2x plus 4 equals 14x. And let's go back to the last slide if I can. There we go. We had the same base, right? We had base 9. That's why we were allowed to make that claim, because these statements were identical, and it was just this one piece that I was able to kind of use intuition, right, to figure out. If I had, let's say, 12 to the 5x equals 10 to the third, I could make no claims about the relationship between these exponents, okay? I have nothing to say about that. It's only when you have the same base. So in this case, I've got 2x plus 4 equals 14x, and just like before, I can solve it in a pretty straightforward way. I will subtract 4, or no, I won't. That doesn't make sense. I'll subtract 2x from both sides of the equation. I end up with 4 is equal to 12x. I divide both sides of the equation by 12, and I get x is equal to 4/12 or 1/3, and that would be my answer in this case. So to recap, we're allowed to make this move only when we have the same base. That goes for both exponential form and logarithmic form. Let's take a look at another example. Alright, so this time you are given the expression 12 to the x minus 11 equals 27, and once again we're asked to find x. Alright, so notice this time that we've only got a variable on one side of the equation, and this more or less is in our standard exponential form, right? We only have an exponent, we only have a variable on one side of the equation. So this fits the form a to the b equals c, doesn't it? It fits the form a to the b equals c. So I am just going to rearrange this. I'm going to rearrange this into logarithmic form, and you'll see why in just a moment. So let's go ahead and do that. Alright, so a to the, let me write out the form as well. So remember, it becomes log base a of c equals b. Now, in general, students can always remember where the base goes. So my base was a, my base over here is a. B and C, the exponent and the result, often get confused. Just remember my sentence. A logarithm is an exponent, and you'll always remember that the exponent ends up on that right-hand side of the equation. So again, a to the b equals c is the same thing as saying log base a of c equals b, or at least that's how I convert from one form to another. It's not really saying the same thing, is it? But that's how I convert from one form to another. All right, so let's do that for our example. So 15 is my base, right? So I'm going to have log base 15. And then we know that my exponent becomes my result. Sorry again about that, guys. Someday I will figure out why it does that. So x minus 5 is my exponent. It's going to become my answer, right? So again, x minus 5 is the same thing as b is my answer. And then 30 is the result. 30 is the same thing as c, so 30 goes right here. All right. Now I didn't color coordinate this one like the one on the first slide of this presentation. So if you need to, feel free to rewind, take another look at that first slide. But notice that by doing this, I've gotten that exponent out, or excuse me, the x, the variable, out of the exponent. I've gotten the x out of the exponent. Okay. So from here, I can actually simplify pretty nicely, right? So all I have to do is add 5 to both sides of the equation, and I get x is equal to log base 15 of 30 plus 5. Now I do want to simplify that, and you've been provided with a logarithm calculator. It's linked in your project. Okay, so all I have to do is type it in. It's going to solve it for me. Couldn't be more simple. So I had log base. It was log base 15, right? Log base 15 of 30. And I'm going to calculate that. And I got approximately 1.25596. Now for you, read the directions. I don't remember which decimal point you're supposed to round to. So for simplicity, I'm going to just write 1.126. I'm going to round to the nearest 100th. 1.126. Again, read yours. See if you're supposed to go to the nearest 100th or what. Rounding incorrectly will cause you to get a wrong answer. Now don't stop here, okay? This isn't your answer. That was just our simplification for log base 15 of 30. I still have to add 5 to it to get my answer. Okay, so again, x equals log base 15 of 30, which I just found out is about 1.126 plus 5. So x is equal to 6.12, approximately equal to 6.126. All right. So not too bad, right? We had something in exponent form. We converted it to logarithmic form, and that was how we got our variable out of the exponent. From there, we had to simplify a logarithm using our logarithmic calculator. All right, so not too bad. You will solve yours, 12 to the x minus 11 equals 27, in a similar way. Okay, next, just more exercises with logarithms and exponents. All right, so your function is f of x equals e to the x plus 2 minus 5. Mine is f of x equals e to the x minus 3 plus 8. So I'm going to run an example. And we're asked to find the inverse. Remember, the inverse is f of negative 1, f to the negative 1 of x. And remember that when we're doing inverses, the main thing we do is we're going to swap x and y, and then simplify, more or less. Okay, this is going to be what we do. So, first, notice that I've got f of x equals e, blah, 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 but I got this f of x. So the first thing you're going to do is just write in y. All right, so I'm going to rewrite the statement, and I'm going to sub in y for f of x. So y equals e to the x minus 3 plus 8. Now I can actually switch places now that I have a y in my equation. So my x's and my y's are going to swap places. So I'm going to end up with x equals e to the y minus 3 plus 8. x equals e to the y minus 3 plus 8. Now, this is what I am trying to isolate. I'm trying to isolate that y, all right? That y is my inverse. So once I get a statement that says y equals something, that's going to be my answer, all right? So how do I isolate this? Well, the first thing I can do, which you can probably see, is I can subtract 8 from both sides. So I get x minus 8 equals e to the y minus 3. Taking the natural log of both sides, remember natural log is basically log base e. Okay, so almost always if we have some problem that deals with e, we're going to be working with natural log. Again, as you know, this is meant to more be a supplemental project video than to really be a lesson concept video. So if you need to, please go review the research section of the lesson to get a better understanding of how to work with e and ln or natural logarithm. So, taking my natural log of both sides, I end up with natural log of x minus 8 equals y minus 3. Again, these are almost, I don't have a succinct way to say this. I don't want to say that these things cancel each other out because they don't. Sufficient to say that this statement is equivalent to this one. Okay, so remember that a logarithm is an exponent. So I've kind of rearranged my logarithm or my natural logarithm, and this is the result of it. Okay, and I'm just going to leave it at that. So this is my new statement. All right, this is my new statement. Natural log of x minus 8 equals y minus 3. My only other thing I need to do is to add 3 to both sides. And my final statement is that y, or f negative 1 of x, is equal to natural log, or ln, x minus 8 plus 3. All right, notice that the plus 3 is not included in the natural logarithm. It was originally part of that exponent, and that's why it has escaped being part of any sort of logarithmic statement. Okay, so you will be able to take a similar track in solving yours. Again, remember, first replace f of x with y, then flip-flop the location of x and y, that's the actual inverting part, and then simplify. All right, so getting that y out of the exponent by applying a natural log, and then rearranging your equation and solving for y, and at which point you can rewrite it as the inverse. So, to summarize the information on how to solve logarithmic spells, the Plaid Wizard needs you to compare and contrast them to other types of spells you have undone. In a paragraph, explain the similarities and differences between solving logarithmic spells and solving other types of spells. So, you've had to do this comparison before. I think you completed lesson 6, and then in lesson 7, I believe, you had to compare back to lesson 6. So it's the same thing here. So, or lesson 8, that's what it was. So we did isolating variables. That was part 1, which was lesson 6. And then I think finding inverses, I'm pretty sure, was the third part, which corresponded to lesson 8. I could be wrong. I think the half-life one was lesson 7. Anyway, so compare what you had to do today as far as undoing spells to what we did for the isolating variables portion of the project and the finding inverses portion of the project. Now, there's not a right way you need to compare them. As always, you know, you're asked to, this is probably going to take about a paragraph. That means 4 or 5 good sentences of explanation. I'm looking for, you know, complete sentences, formal writing. Don't assume that your audience knows anything, so make sure to explain things fully, as if you're speaking to an audience that needs to be taught the information, not an audience that already knows the information. All right, so I hope this helped. I'll see you guys next time.